Hi guys, welcome to Linkside YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's in this video? In this video we will talk about Kubernetes Replica Set. So guys, let's begin the topic. But before start the lab session, we need to understand few points, which is what is Replica Set and their use cases in Kubernetes cluster. As per the Kubernetes documentation, Replica Set is a Kubernetes resources which is used to maintain a specified number of identical pods known as replica within a cluster. It is a controller that ensures that a specified number of pods, replicas are running at any given time. It is used to automatically replace any pods that fail, get deleted or terminated, ensuring the desired number of replicas are always available to serve the request. When a replica set is created, it creates the desired number of replicas of the specified pod. It then continuously monitors the status of the replicas to ensure that the desired number is always maintained, right? So this is the official documentation of Kubernetes from where we can get the replica set information in deep drive. So in this demo we will see how we can work with the replica set in Kubernetes cluster. Let's begin the lab session. Okay, so I'm on my Linux VM. Currently you can see I'm working on a single Linux machine where I have already installed Minikube single node Kubernetes cluster. Let me show you the OS release version of this machine and then Minikube status. So get etc version release, this is 9.3, and if I talk about Minikube status, it's up and running condition, right? Before moving to next, we need to verify the status of cluster also. So to check the node availability in the cluster, we need to run the command kubectl get nodes. So here you can see my Minikube node is ready condition. Once you have node available in the cluster, you are ready to create your first pod. So now we will check the list of the pod in the default namespace. Command is kubectl get pods. Okay, no resource found in the default namespace. Since this will be our first pod on the cluster, so you will not see any pod in the default namespace. Let's check the service availability also in the cluster. Command is get svc services. Okay, so here you can see one default cluster IP service is running in the default namespace for Kubernetes cluster on port number 443. Currently I don't have any node port service running on this cluster for expose my application to the external client. So let's move to the first step, which is launch our pod using replica set in Kubernetes cluster. So let's create a file in my dedicated directory with a block of code. So I'll move to my ks directory, kts, and let me make a replica set rs.yaml. The code could be based on JSON or YAML format. Replica set pod creation code is available on the Kubernetes documentation. You can grab it from there. Let me go back on the documentation. I'll show you where it is. Just scroll down here and here's the complete code. See, the kind is replica set and that code is there. So I have already copied this code and modified as per my scenario. So let me copy the code from my notepad and paste it here, and then I will explain the entire entries that was used to create our replica set, right? So I'm back on my notepad file, and here let me copy and paste it inside here. Let me save it. Okay, yeah, here it is. So go with the first one, API version. The API version field specifies the version of the Kubernetes API that the object is using. The API version for this object is currently app/v1, right? The kind field specifies the type of object that this file represents. In this case, it is a replica set. Then the second is metadata field. Metadata field contains metadata about the replica set. Here we are defined the name by which we can refer to this replica set. Then specification part is mandatory in the replica set object. The spec fields contains the specification for the replica set. It includes the following fields. First of all, replicas here. So replica, the number of the replica of the pod that should be running at given time. It default to 1 if it was not specified. So here I set it 3. It means 3 pods should exist at all the times. Second is selector. Selector is a label query that determines which pod should be managed by the replica set. Then the third is template. The pod template that will be used to create a new pods when the replica set needs to scale up or down. So the template field contains few more following fields, which is metadata. Metadata for the pod. Then specification, the specification for the pod. So the spec field for the pod includes a container fields which specify the containers that should be run in the pod. In this case, there is a single container named my container, and this is based on the Nginx latest image and exposed on port number 80. So in short, here we are defining a replica set named my replica set. Here it is with the 3 replicas, and the replica set use a pod template with the my app label. This is important, and the pod specification includes a container named my container using the Nginx image and exposed on port number 80. So now my replica set file is ready. Let's deploy using the kubectl apply command. So I'm save and quit from here. Let me save and quit, and I will run the command kubectl apply -f rs.yaml replicaset.yaml. Yeah, it's created. Once the replica set is running, you can check the status using kubectl get rs command. So I can go back on get rs replica set. See, desire is 3, current is 3, ready is only 1, ready is 2, let me go ready 3. Yeah, so here you can see 3 out of 3 is ready. So the first field is name. This is the name of the replica set declared as the child of the metadata property. Second is desire. This is the replica number specified in the YAML mainface file. Third one is current. This is equal to the current state of the replica set, that 3 replicas are up. Then the ready, the 3 replicas specified are ready and it is in running state. And the last one is age, how long the replica have been running in the running state. So currently it is in 17 seconds. So let's view the replica set more details using the describe command. So you can go with kubectl describe replica set. You can short in rs and your replica set name my replica -set. So we can get the deep information about that one. So here you can see 3 out of 3 replica 3 current, 3 desire, right? So 3 out of 3 set are ready in desire as well as in current state, and all 3 pods are in running condition, right? The pod status in running condition. So we can check the status of pod running in the replica set using get pod command. So let me go back, kubectl get pods -show labels labels. So here you can see all pod are in running condition. So let's move to the next step, which is create node pod services for exposing my application to the outside from the cluster. So for that one, what I will do, I will use to create a service file. So service.yaml. Now this code is for the code of our service is also available in the Kubernetes documentation as node pod service. So let me copy one more time from my notepad. Here is the service file. Let me copy, then I will explain what the things are there. Okay, now I'm going to explain it. So this YAML file defines a Kubernetes service object of type node pod. Here you can see it's a node pod, right? And the selector block instruct the node pod service to send incoming traffic to one of the pods with this label. So in my case, the label is app my app. That's important. So node pod tells Kubernetes pod to open to the outside of the world on all of the worker node. This field tells Kubernetes to expose the service on port 32,000 on every node in the clusters. That is a node pod. Second is port. Port specifies the port that should be open to the cluster internally. Incoming connections will be accepted on this port only if they come from within the cluster. External connections won't be accepted on this port. In our case, it is 8181. Then the target port here it is, that is 80. So this service will be forward incoming connection to one of the pods it's exposed. Target port specify on which port of the pod to send traffic with this config. Even if the traffic comes to port 32,000 on the node, it will be sent to the port 80 of the pod, the target port. And the final we have selector. So specify a label selector that defines which pod should be exposed by this service. In this example, the service will expose all pods that have the label app with the value my app, right? So my service file is also ready. Let me deploy. So going back and run the same command one more time, service dot sorry, let me make it service dot, it should be dot YAML. Okay, so kubectl apply hyphen f service.yaml file. Perfect. Now let's check the status. Kubectl get svc services. Perfect. So here you can see new service named backend is ready with the new cluster IP 10.99.239.229 and the type is not port and running on the port 32,000, right? It is ready. So my node port service is ready. Time to check my application output. So let's get the public IP of my Kubernetes node using the kubectl get nodes -o void. So this is the IP address of my Kubernetes minicode cluster, right? So let it be copy and try to hit from here using Firefox the IP address of the machine colon 32,000 and go with the ampersand. Okay, now I try on the node port IP plus port, and soon I will get the result. If everything is okay, we will get the Nginx welcome web page. Okay, let's see, it's coming up. Yep, here it is. So see, we can access the Nginx welcome web page from outside of the cluster. That means it's working fine. So now move to the next step, which is scaling the replica set, which is very important. You can easily change the number of pods or a particular replica set managed in two ways. Two different methods are there. First method is you can edit the configuration file we created earlier in this demo by changing the replicas property value to higher number to scale up or lower number to scale down. Or second method is that from command line using kubectl scale command directly. So the recommended practice is always to use the replica set template for creating and managing the pods. So let me scale up by the first method. So to scale up, we need to edit the manifest file and change the replicas value from 3 to 5 or whatever you want, and then we will see the result. So I'll go with the replica set YAML. I'll modify it from 3 to, let me go for 5. Okay, I save and quit, and now I need to replace it. So we can replace with the kubectl replace command -f rs.services. Okay, as soon as I press enter, I'll go with the get replica set. So here you can see 5, current 5, 3, okay, 4, soon it will be, yeah, here it is. You can see that earlier the 3 is ready, now 4 is ready, now 5 out of 5. I got the exact result what I want. See, replica set is entry change from 3 to 5. Now we can check the status of pod running the replica set get pods command also. Kubectl get pods. See, all 5 are running, right? So in the same manner, what we can do, we can scale down also. So if you want to scale down, just go and follow the same thing. Replicas replace 5 with 1. Suppose I want to go with only 1, and then we run to command replace, and then we can check with get rs status and get pod. So here you can see the number of replica and the running instance of pod are the same as the number specified in the manifest file replica field. So in this is the first method, which is always recommended. Even we can use the second method. Let me show you from my notepad. I have write down the command over there. This is the command, right? So kubectl scale. So a kubectl scale command, we can use the followed by the replica set name and desired replica count. So I can run the kubectl scale replicas, how many number of replica you want, say 5 or 1, whatever, and the replica set and your replica set name. So in my case, this is the replica name, replica set name, whatever I have done it here, my replica set. So by this command line tool, we can also use the same pattern, and we can up and down the scale up and scale down, right, in the same manner. So this is the second method to scale up and scale down number of replica set by using command line method. Total choice up to you, but the recommendation is always go with the configuration file. So let's move to the last part, how we can delete the replica set. You can also use the same file that used to create the resources and possibly other resources definition as well to delete the resources by using kubectl delete command. So let me go back kubectl delete delete -f. First of all, let me remove the replica set, and then I want to remove my service file also. Perfect. So this above command will delete the replica set and all the ports that it is managed, as well as node pod services. So let me check. So first of all, I go with kubectl. Let me check the pod status, all gone. Let me check the replica set, all gone. And let me go with svc. See, node pod service is also gone. So all entry are gone. I am back on my default condition. So guys, that's all about this replica set and its demonstration. Hopefully you enjoyed and you learned things. Soon I will come up with another new interesting topic. Till then, keep practicing. If you feel something I have missed or you wanted to know more something else, please reach out through my social media links, which is mentioned in the description. And if you like this video, please do not forget to like, share and subscribe my channel and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.